We're on.
Hello, everybody. Welcome to the webinar. This is Paul Ferrara, Communications Accessibility Editor at APH. We're letting you in.
And I'm going to go ahead and bring up our PowerPoint and start it from the beginning. All right, so that's ready to go once we review the poll.
All right, we're going to end polling and share the results.
Anything of note to point out in the polls?
Oh, I'm sorry, I forgot that was me. So where are you from? For the Northeast, we have about 30%, so that from the Northeast and the Southwest. So thank you guys for joining us. A few international today. For those who are hearing about this, how did you hear about this webinar? Mostly got notified by an email from APH, some from the website, and some from the ACV REP website. In terms of job titles here with us today, about 40% are TVIs, 18% are O&M instructors. And we got a few other folks joining us today, so welcome. In terms of how comfortable our audience today is teaching computer coding courses, most say not at all comfortable. So hopefully today you'll learn some tips and tricks to use CodeJumper to teach STEM and STEAM coding in your classroom. For question 5, do students have any IEP goals that are written around STEM or STEAM learning? The majority at 43% said no, 21% said yes, and 36% said not applicable. And finally, do you believe that the school districts you work in are interested in your students accessing STEM and STEAM curriculum? The majority did say yes, at 71%. So hopefully we've got a really captive audience here with us today who are very interested in CodeJumper and what we have to learn today.
Thank you very much, Betsy Ann. So welcome, everybody. One more time, this is CodeJumper, a universal design for learning solution for computer science education. And we hope that we can assist you today. And let's talk about some challenges you might be facing. So are any of these things familiar to you? You run into situations where you're dealing with computer science learning tools that can't be adapted. There's no way to change their interfaces and make them easier to use or more accessible. More specifically, maybe you run into something that is mouse only and there's no way to interact with it with a keyboard. Maybe it requires click and drag, and maybe it could work okay, but it has unlabeled buttons, so a student using a screen reader wouldn't know what the buttons do. Maybe it's got animations without any kind of dialogues or sound, so all you've got is visual feedback. Maybe your students are just not able to engage in classroom activities for one or more of these reasons. Maybe there's just the curriculum just doesn't work for all students for whatever reason. If any of those challenges are familiar to you, we'll try to address those for you today and show you how CodeJumper can fix some of those problems. Joining us today in Access Academy, Greg Stilson and Jim Sullivan from APH. Greg Stilson, Senior Director of Global Innovation, and Jim Sullivan, Director of Social Enterprise. Our learning objectives today, what are we going to be doing? So you're going to be able to describe at least 3 ways that CodeJumper can engage students in learning block code. We're also going to be able to list at least 3 ways students can express their understanding of block coding concepts using CodeJumper. And we'll compare CodeJumper content with 2 other block coding programs. Very important for us to understand how those programs are similar and how those are different. And now with that, let's turn it over to Sully.
Thank you, Paul, and welcome everyone. I am Jim Sullivan. Oftentimes I'm on the other end of the Access Academy. It's good to be out here in the front end presenting to you today. As we start out, I'm going to ask Betsy Ann to drop into the chat the codejumper.com website, as well as a resource that I used for some of the preparation for this presentation today. And so as we move through, we're going to talk a little bit about learner variability, and we're going to go into a bit of information about universal design for learning. We're going to talk a little bit about what CodeJumper is, how it relates to Blockly and a program called Scratch. We're going to get into some of the different pods, talk about one of the lesson plans, and actually demonstrate the product around one of the lesson plans, specifically debugging, and then head in and wrap up and maybe get to more some of those Wisconsin trivia questions. Right? I wanted to start out with this idea of, could you imagine? And so on the screen is sort of this Zen-like picture of these rocks that are stacked sort of perfectly in this really cool, comfortable sort of greenish background. But can you imagine a scenario or a situation where, as educational professionals were planning out and considering what curriculum they were going to adopt, that they considered learner variability? So the goals, the methods of instruction, the actual assessments themselves and the materials, all of those we're taking into learner variability. It sounds like sort of a perfect world, a world that many of you, I'm sure, would like to be learning in, or perhaps teaching in, or administering in. So this idea of learner variability, when we think about learning variability, we think about the idea of what's going to attract the attention and engage the interest in a student. Many of you now are spending a lot of time working from home, and perhaps a few of you have actually adopted some of those stand-up desks. How many of you work a little bit better when you're standing up versus sitting down, right? How does that help you to engage in the work that you're doing? Considering things like that, many of you who are in the classroom know those kids that when they go into the computer lab, they perk up a little bit, that they get more interested and they become more engaged. Or when they get out of their desks and they go over for small group instruction, you see them sit up a little higher, or maybe respond a little bit faster. So considering again how to engage students in that development and adoption of curriculum really thinks about learner variability. Another aspect of learner variability would be how students perceive or understand or use information. So how many of you have kids that would prefer to look at something, or where there's a chart or a graph, they tend to pick up on it a little bit faster? Or for our students out there who read Braille, they prefer to maybe read Braille when they're doing math and when they're doing science. But when they're in English language arts, they'd rather listen because they could perhaps get through that information a little bit faster. And then the third point here is, how do students then navigate the learning environment and express what it is that they've learned? In scenarios where there are multiple ways to navigate those environments, and enabling kids to be able to maybe record what it is that they've learned, or write out in Braille what it is that they've learned, or maybe in small group discussion, they're better at talking about what it is that they've learned. And when they go to try to take what they're speaking and put it to paper using a pencil, things break down. Well, those are all things that would be taken into consideration with regard to learner variability. And so when we plan for multiple ways to develop interests and regulate attention, when we plan for multiple ways of presenting information, and when we plan for multiple ways of expressing understanding, we really create a scenario where we are using universal design for learning. And I'm hoping that for many of you, the concept of the idea of universal design for learning is not new, that you've been hearing about it for a while. And as we move through this, what we really want to do is sort of point out how CodeJumper is this tool that is really ideal for a learning design, universal design for learning experience. and for the reasons that I mentioned previously. So what are the tenets of universal design for learning? They include engagement, expression, and representation. So again, a scenario where maybe kids have the opportunity to be able to stand up or sit down, work in a computer lab, maybe do something with video, do something with a recording. Expression, opportunities for kids to be able to talk about what it is that they've learned, type out what it is that they've learned, write out what it is that they've learned, or braille out. And then representation, the opportunity for kids to be able to listen, or to be able to view, or to be able to, again, read in braille. When we talk about universal design for learning, and we talk about learner variability, we're talking about engagement, expression, and representation. And there will be multiple tests throughout the day, and this will be one of the tests, just warning you. I'm going to move forward, and so we'll raise the question, how does CodeJumper address the tenets of universal design for learning? And I'm about to switch gears and throw it over to my good friend, Greg Stilson. But before we do that, we're going to go ahead and we're going to throw out our first poll question of the day. And we're going to open up and close the chat. Now would be an opportunity, if you have questions, to go ahead and drop any questions that you have in the chat.
All right. Thanks, Sully. Here's our first poll question. Choose the 3 tenets of universal design for learning. So we do want you to pick 3. Your choices: expression, Taoism, representation, engagement, and good living. Which of those 3? Expression, Taoism, representation, engagement, and good living.
Feel free to throw those in the chat as well if you.
Yeah, if you have trouble accessing the poll for whatever reason, feel free to throw those in the chat.
We are looking for high participation here in this poll, everybody, too. Tells us that you're not nodding off out there in San Diego, California, or Biloxi, Mississippi, or Madison, Wisconsin, for that matter.
We're still here. Still raring to go.
All right, looks like most have voted. The ones that are rising to the top, looks like everybody's paying attention out there. Expression, 97%, representation, 97%, and engagement, also around 97%. We didn't trip you up with Taoism or good living. So congratulations, everyone. We're going to close the poll. And you can see those results right there.
Gregory, you are on.
Awesome. All right. So if we talk about how CodeJumper can address these tenets of UDL, right? So when you look at things like engagement, right? So first off, there's multiple ways to engage students. What's really cool about CodeJumper, and Sully, I'll actually have you jump to what is the CodeJumper slide so I can at least kind of show people what they're looking at here. When you look at engagement, one of the biggest things, and we all know that you can't engage 2 learners the exact same way, right? Some people are engaged via a tactile method. Some people are engaged more with audio. Some people are engaged visually. The cool thing about CodeJumper is it's an inclusive product, meaning that it can engage folks both with audio, with tactile, with visual. There's bright colors. So being able to engage students in multiple ways is something that CodeJumper can do. You can represent the way that you want different coding threads and things like that to be done in multiple different ways, whether you want to use different pods and things like that. And students can express what they learn in really creative ways. So when you actually look at what CodeJumper is, it's actually a physical coding tool, right? So, and we'll get into comparable things here in a second, but it's a physical device or kit, I would say, that allows you to physically create a lot of the same concepts that are done in things like Scratch or tools like Blockly games and things like that. those other options traditionally had not been accessible, requiring click and drag, actually using animations to represent concepts. Here, you actually have physical pods that can be connected together to create the different the different examples and pieces of code and threads that you want to create. So I'm going to have you jump to the next slide there, Sully.
Okay.
So if you, as I mentioned, it's very similar to the block style coding. It teaches what's really cool about this is when you actually connect a pod to the hub, you'll get a physical click, and Sully will show that here in a second, telling you that that pod has been connected. There are multiple types of pods, which we'll go into. They all have different textures, colors, and shapes that you'll feel. And students can create different songs, stories, poems, and they can get their own and create their own sound effects that can be used to create different things as well. So go ahead and jump to the next slide.
All right, so do you want me to go back to Scratch and Blockly? Because if we go to the next slide, we're going to start talking about...
Yeah, why don't we do that quick? Just to comment that many of you probably in the mainstream courses have used Scratch and Blockly games and other tools that have used Blockly to create, to really build that foundation of programming understanding or computer programming understanding. You build this foundation by creating an understanding of what is a loop, what is a constant, what is an if-else statement, and really what those are apps or applications that run on computers or mobile devices that use these different type of coding blocks to build a thread of code. The problem is that traditionally those applications and tools have not been accessible, requiring students to click and drag, resulting in an animation visually stimulating somebody, but not being able to really get that point across to our visually impaired learners. I have not looked at Scratch recently. I have heard that there have been accessibility improvements. However, one of the things that I want to emphasize here is that when you look at CodeJumper, even if Scratch was tremendously accessible, one of the things that it doesn't do is really create that tactile stimulation, to be able to really create that tactile understanding for a multimodal learner. Let's jump forward to the app real quick, Sully, just so I can talk about kind of how this connects to the pods.
All right, we are at a slide of the
Beautiful.
app right now.
Awesome. So the kit, all those pods will connect to a hub. That hub connects to your Windows-based laptop, or very shortly, if it's not already on the Google Play Store, we will be releasing an Android version of CodeJumper as well that will run on Android tablets and Chromebooks. To be able to allow you to connect your hub via Bluetooth to the app running on any of these platforms, whether it's Windows, Android, or Chromebook. And what that does is, as soon as you connect your hub via Bluetooth to this app, when you connect those pods to your hub, it basically starts to build the pieces of code or the blocks of code based on whatever exercise you're doing. So, for example, a student could choose to build the song Row, Row, Row Your Boat, using different parts of that song and using different pods to create the thread of that song. And you could do it via whatever it is, 7 Playpods or whatever to play it, and Sully's going to go through that here in a second. Or you can do some really creative things with loops and if-else statements to be able to create it in much more efficient ways. And I think that ultimately is what gets the point across to students, is that you can do it one way that may be incredibly inefficient, and that's the way it is with computer programming as well. You can build multiple lines of code to accomplish something, or you can do it really efficiently with, say, 2 lines of code. But that application can be found on the Windows Store, will be able to be found on the Google Play Store on both Android or Chromebook. It is a free download, and you need it with the purchase of the CodeJumper kit. So let's get into a little bit about the parts and pieces of the CodeJumper kit individually. I think, Sully, you wanted to show these in person. Is that right?
I did, and I just did Zoom Jiu-Jitsu, and I'm
Nice.
hoping that as a result of doing Zoom Jiu-Jitsu, that our audience that are light dependent, because we'll describe all of this on the left-hand side, should see the
Nice.
Jumper application, and then on the right-hand side, you will see the Sullivan poker table that gets used mostly for games, and you will see the hub. So take it away, Greg. I will describe the hub.
You have
Or
been
you describe the hub. I'm in a point.
you have been upgraded to Zoom MMA fighter now, so there you go. So the hub is a sort of oval-shaped device that has two buttons on it and a volume dial. To turn it on, you just simply turn that volume dial. You'll get a click to turn it on, and then you can raise or lower the volume just by turning it. Super simple. There's a triangle and a square button, and those are used to play your code or to pause it, or if you push them both at the same time, you can actually have the computer read the code that you put in, but not using the sound effects, but rather using the more technical understanding of what you made. On the front of the hub are four thread inputs, and those threads, you can run multiple threads of code at one time. A lot of the beginner exercises and things like that will have you only using one, but as you progress through the curriculum in CodeJumper, you'll get to actually run multiple threads at one time, doing some pretty cool acrobatics with pausing and being able to switch back and forth between threads and things like that. So that does enable you to run 4 threads at a time. It runs on AA batteries, so there's no special batteries to charge or to run from, and those just get installed in the back of it.
Right.
Let's
Okay,
move.
so we're gonna, Greg is gonna go into some detail about each one of the pods, but before we do that, we can get a little tricky. All right, so we're going to change our sound set to a custom sound set. So I'm going to go into custom sounds, and the sound set is specifically music today. And so just briefly, I can add custom sounds to this. So when we talk about engagement, what's going to engage a student? Is Twinkle Twinkle Little Star going to engage them? Or are maybe some space sounds or some car sounds, or maybe other sounds that are particular to something that is core to them or core to a group of them. And so to add a custom sound within the app, I would go to sounds, and I'm not sure how well I'm going to be able to do that, but I would choose add sound set, and then let me just pull this over. I need to maximize this a little bit, which, well, let's just go ahead and do it. So I'm going to maximize that a little bit. So I can come here and specifically for music today, you could see the sounds that I have selected here. They range from boom chuck to driving force to the 6th sound is not added. So I can click on this 6th sound where there's no sound, and I can click add. I will go into add sound file, which will take me then into my desktop where I've got some sounds selected. So here's first beat. So I'll go ahead and select first beat. And I'll click on open. And then I'll enter the name, first beat, and then hit done. Whoop. First beat is already in use. But that gives you a little sense of how I can come in and I can create those managed sounds. So let me go back here to home and then minimize this, so, or maximize, or just place this on the screen for everyone. The Zoom Jiu-Jitsu is causing me just a little bit of headache at the moment.
I think you're starting to get choked out a little bit.
Yeah. All right, so I'm going to go in, and again, our custom sound set is music today. So Greg will get to learn a little bit about what's in the music today sound set. So with that, Greg, do you want to go ahead and describe the Playpod?
Absolutely. I'm waiting for a little bit of 80s hairband, so here we go. So what as I said, the kit consists of multiple pods, multiple types of pods that do different things. The first one, and the one that's going to be the most prevalent in all of the exercises that you do, is called the Playpod. And Sully, refresh my memory visually what color that is, because I can't see it.
It would be a nice shade of powderish blue.
All right, so a powdery blue Playpod. That consists of two different tactile knobs. The larger knob that is more flat in nature is the knob that will allow you to select the individual sounds. So what you'll do is connect that Playpod to the hub. So Sully, if you want to connect it, and we get a little click sound.
Got it on the wrong one. Hold on. I got a little reverse action going on here. All right. Now we're ready.
We got an audio click sound that came from the computer, or it can come from the hub as well. And Sully can actually turn that flat dial to tell us which sound we want to play. So that was a big beat. There you go. Nice. So he can select any one of those sound effects that he wants, and he can set the tempo of that to be whatever he wants using the second dial, the more raised up, smaller dial. So he can have it go faster, higher pitched, or slower, lower pitched, depending on what he wants to do. So if we move on to the next pod, and as you build these threads of code, what you're going to do is you can string multiple play pods together to play different sound effects. But ultimately, what you're going to do is move to different pods, like the pause pod, for example. And what that means is you can actually set, if you plug in that pause pod, you could even you can set it to whatever there. It has one dial. And Sully, what color is that one? Is that orange?
That would be orange.
All right. Okay. See, there you go. So it has one dial on it. And what this does is it allows you to pause a thread of code for a set number of times. So I think Sully just right there said 2 beats, for example. You can set it for, I think, anywhere from a half a beat to 2 beats all the way up.
1 beat.
Yep. And as you are turning that, you set that to pause. And what a lot of the exercises that you're going to do here is it will actually allow you to do something on another thread while this current thread is paused. So you can have multiple threads going on, and while one is paused, you can be doing something on another thread to make a different song, a different beat, a round, whatever you want to do. The loop pod, if we move forward, I think that's a yellow pod. Is that right?
That's right.
All right, see, my color memorization here is one of the more important concepts that I think CodeJumper shows better than any other tool for young students really developing that foundation of coding. As a former programming major in college, I really my brain just did not grasp a lot of the concepts. And I can tell you that what this loop pod does is it physically creates a loop for the student to understand. So the loop pod has two cables that come out of it. One cable is used to connect it to the hub or to the existing thread so that you progress to the loop. But then what you do is you take a play pod and you put it inside the loop. So there's two additional jacks or plugs that you can plug it into. And so what Sully's going to do here is he could actually plug in the loop into the existing thread with the shorter of the two cables, and that will connect the loop pod to the existing thread. And then what he will do is he'll take a play pod and he'll plug that into one of the jacks that is inside the loop. And using the longer cable from the loop pod, he'll loop it around and connect it to the jack that's on the back of the play pod. And so Sully, if you can show that now.
Yep, I've been doing
Got
that.
it. Perfect. Very cool. So visually, you visually see that it is now looped, and what is inside that loop is the play pod. On that play pod is a yellow dial, and what that dial does is it allows you to set how many times this is going to loop. So for example, you may have an objective that you need to, for example, row your boat. Well, we could string together 3 play pods set to row at one time. Or what you could do is put 1 play pod set to row in a loop, and then turn that dial to the number 3 and allow it to loop 3 times before it exits the loop. Then the last thing you would do is take, say, another play pod or a different pod, and you'd connect it to that last plug or jack that's on the loop pod, so that when it's done looping, it then knows that it should leave the loop and move on to the next part of the sequence. Okay? I hope that makes sense. The loop pod, I would say, out of any of them, is the toughest one to explain without tactily feeling it.
So right now, in our example, the first play pod is going to play driving force at normal speed. The second play pod, which is connected to the loop pod, is going to play first beat, and it's going to play it 3 times. Shall we play that for them, Greg?
Go ahead. Yep.
All right, here we go. By pressing the play button, that's the circle button with the triangle, away we go. So I hope everybody was kind of getting their shoulders moving a little bit out there with that, that half speed first beat.
Nice. So the next 2 pods I want to talk about are the selection and the merge pods. So the selection pod is your typical if-else statement, okay? And what that does is it allows you to basically set 2 paths that you can take in a thread. You can say if, and then you can set a number. So for example, if 7 is greater than 2, then go to this side. So the selection pod basically has 2 jacks that you can plug into it. So you connect the selection pod to your existing thread with the cable, and then off the back of the selection pod there is 2 jacks that allow you to plug additional play pods into. So and then for each one of those jacks there's a dial that you can set a number to. So for example, if 7 is greater than 2, Sully can plug in a play pod and set it to play something. If, let's just say, if 2 is not greater than 7, or 2 is 2, if it turns out that if 2 is less than 7, then at that point it would go to the other side and it would play a different sound effect. And we'll get into the constants and variables in a second, but you can actually plug in some random things so that the outcome can be randomized at that point. So once you've connected those the if else or the selection pod there, it's now going to take a path and go down one side of that thread. So whatever side it's chosen, now it's going to play that sound effect. And the next thing that you're going to do is to bring it back together, so that, because you've split your thread now with that selection pod, right? So you've got now 2 potential outcomes. You now need to bring it back together to continue your thread of code. And that's where we use the merge pod. What the merge pod does is it's basically a pod that has 2 cables coming out of it, and you plug both those cables into the backs of the 2 play pods that you've separated out to different paths. And then on the other side of that merge pod is 1 jack that allows you to now start continuing your thread of code with 1 play pod or a different pod that you choose. There you go.
So we can take a moment. I've plugged in the selection pod into the hub. It is represented in the second thread that's up here. And so it says right now, if 1 is greater than 4, then play snare drum for 5 half-time speed. Else play hi-hat 2 for 2 times speed. And that ends the if statement, followed by a pause pod that I played at the end. And so if I adjust the selection pod with the 2 spokes on it,
2,
we can bring that up.
3, 4, 5.
And then if I select the knob with 3 spokes,
3,
we can bring that down lower,
2,
right? And then if I press the play, playing the snare drum
Snare
for
drum.
me.
There you go.
Yep.
Yep. And then what he's doing then is it's merging. It'll merge back together so that he can continue his thread after that. The last thing I want to talk about from moving away from pods is these what are called constant and variable plugs. These are little plugs that you can plug into the existing jacks that are inside those rotating dials. Okay, so for example, there's jacks that range anywhere from, I think it's 1 to 8, I want to say. I don't remember. I haven't looked at these in a while, but you can tactily feel on the top of those jacks the number that you're looking at. Having said that, there's a jack in there called the infinity jack, or the infinity plug, that you can plug in, and it will actually override whatever number you have with an infinite option. So you TVIs, if your student really wants to mess around, they could plug that infinity plug right into your loop pod and create an infinite loop that will just go forever and ever and ever. So, but there's also a random one that has an R symbol in it. And that's really interesting, and it'll be used in some of the exercises that we talk about, because what it does is it overrides the numbers in those selection pods. So normally you'd say if 7 is greater than 2, then go this way. But what you could also do is say if 7 is greater than, and then create the random. Sometimes it won't go that way because maybe the random number on the other side is going to be 8 or 9 or whatever. So having said all that, these plugs add an extra level of variable and complexity to it as well. So that, in general, is the Code Jumper kit and how you'd string those pieces together. And Sully, before we finish that, if you wouldn't mind, I want to show. We talked about how we played the different sound effects and things like that. Sully was reading the code that was on the screen. So when you talk about that loop or the if-else statement, Sully was actually reading that. If Sully were to press the play and the pause button on the hub itself, if you want to push those together, Sully, I just want to give an example of what that sounds like. You can actually get the computer to read that to you.
All right, I'm getting ready. I've got our selection, 2 play pods, and then we'll round that out. And I am going to press the 2 smaller buttons. Let me see if I can get those into the screen. Again, one with the triangle and one with the square. I'm going to press those simultaneously.
Thread 1 music today. If 5 is greater than 2, play driving force normal speed. Else, play first beat half speed. And if, end thread.
So you heard that it actually opened up the if statement, it read this statement, but then it actually ended the if statement, and had there been more connected pods, it would have moved on to the next piece of the puzzle there. But then you heard it say end thread, so it tells you when the thread is beginning and ending. So that's a really handy tool once your student starts to understand the block concepts more than just the sound effects, that there's actually some code behind it as well. That's really a good way to start to grasp the concept of opening and closing pieces, opening and closing parts of a thread of code and things like that. And it's sort of a nice transitional piece to actually transitioning to text-based code down the road. So
why don't we do one of our poll questions just
Sure.
to make sure that everybody is still with us, to talk about specifically what Code Jumper teaches.
Awesome. So I'm going to launch the poll. And I've also opened up the chat. If you have any questions you'd like to drop in, we can keep a running tally of those questions. And Greg can hopefully get back to those during our webinar. So please go ahead and take that poll and drop any questions you have in the chat.
And to go through the poll question, it is Code Jumper is designed to teach which one of these? Pick one answer. Computer assisted drawing, computer programming concepts, woodworking, or physical education. Computer assisted drawing, computer programming concepts, woodworking, or physical education.
All right, so as those are coming in, do we have any questions that have been dropped into the chat?
No questions so far. Looks like everybody is on board with us. No one, we didn't lose anyone. Everybody's agreeing that CodeJumper is designed to teach computer programming concepts. One question just dropped in the chat. Does the package itself or app include sequence lesson plans with it?
So it includes an entire curriculum. So this is a set of exercises and plans that you can use to go through the entire curriculum with your student, from super basic unplugged things that have that you don't even need the kit to do, all the way up to some pretty advanced threads and things that you can do with your student. And I think Sully is going to go through an example here shortly of one of those kind of exercises.
That's a great segue. So if you're out there now and you go to codejumper.com, you are able to actually pull up the lesson plans themselves. And so we'll talk a little bit about the resources. So resources include lesson plans. There are 8 primary lessons that advance from sequences to algorithms to debugging, and then 11 advanced lessons that include everything from constants to nested loops. What's nice too about CodeJumper is that it provides an opportunity really to do 2 assessments, and then there is also the opportunity for the students to be able to journal during each lessons, and outlines are provided to guide that journaling. And if we go back to, again, that idea of expression, right? If you've got students who are Braille readers, if you've got students who have low vision, if you've got students that would prefer to record, or if someone's going to subscribe, they have that outline that they're going to follow as they go through each one of those lessons. And at the conclusion of the primary lesson and the advanced lesson, there are 2 assessments that ask the students to do projects. And those assessments include rubrics to allow you to be able to score. So when they get into, again, expressing what it is that they know, they're going to do that specifically with this tangible tool that allows them to be able to do coding. So in addition to the resources, there's obviously a user's guide there as well, but there are 8 CodeJumper tutorial videos as well that range from a description of the hub to what a selection and what a merge pod is. So when we started out this presentation a little while ago, we asked the question, how many of you feel comfortable with teaching computer science? And there's one Jedi who's hopefully still out there with us who responded, I feel very comfortable teaching computer coding. The vast majority of you said, nope, it's not something that I'm comfortable with. And really, you ask the question, is it something that you personally should be responsible for, or somebody within the district that you're working with who might be doing that? But what you can bring forward to them are these lessons with these means of being able to assess and to be able to engage and allow the kids to be able to express, and then enable them or represent what's going on with some of those lessons and what they need to do in really very, very dynamic ways. And so what I thought we would do for the purposes of a demo here in a moment is to actually walk a little bit through the debugging curriculum. But just to give you a sense of how the curriculum and the format flows, these lessons typically begin with an unplugged activity, and then they get into a guided activity. They move to exploration, that check for understanding, right? That ability to be able to come back and to be able to review the student's journal to confirm that they do understand what's going on, and then finally that assessment piece. So that is the overall flow. A lesson itself consists of expected outcomes, key vocabulary, resources specifically, and what's nice, and I really should cite this, is throughout the lessons, they specifically reference the national curriculum standards related to computer science. And so how each one of these lessons and these activities are meeting up with some of those national standards, which again could help you as you were going to districts to talk with them about what the solution was and why it was appropriate, the ability to be able to point to how this tool will meet some of those standards. There are objectives, instruction, there's closure, and then there's student journal itself. Right, so what I thought we would do is talk about debugging a bit and then go into a demonstration and wrap up. So with regard to debugging, the lesson objectives are to understand the concept of a bug in a computer program, and then to identify and fix simple bugs in their own program. So those are the lesson objectives. Whoops, I should have vocabulary. So the vocabulary specifically in this lesson is a bug. So a bug is an error or a problem within a computer program. And debugging is the process of finding and fixing bugs or errors in a computer program. And then a software engineer is an engineer who writes computer programs for different types of software. So that's what we're going to be checking for. There'll be a test here in a little bit. So our vocabulary is bug, debugging, and software. Now, I thought what I would do is kind of start with a plugged in, unplugged activity. And that is sort of getting into that idea of a sequence of things and what's wrong in the sequence of things and how do you go about fixing or changing. And so I thought I would do state capitals. Assume everybody here is familiar with state capitals, and we'll test a little bit of your knowledge. And what I'm going to do is I'm going to play 4 recordings. It's me naming the state and the state capital. And what I need you to do is tune in and identify which is the incorrect state capital. And we would need to come to an agreement, right? And if you think about engaging the kids, if you're doing this, do all of your kids know the state capitals? At what age would you do something like this with this plugged in, quote unquote, unplugged activity? And is this going to engage the kids? CodeJumper itself for this particular activity actually provides cards with math expressions. They, I believe, are addition and subtraction, if I'm not mistaken. And so the kids would lay out the cards and then go through the math expressions and identify which was the incorrect math expression. So listen up, here we go. Our plugged in, unplugged state capital activity. Greg, you and I will work on this together, okay? Here we go.
Columbus is the capital of Ohio. Louisville is the capital of Kentucky. Lansing is the capital of Michigan. Harrisburg is the capital of Pennsylvania. Richmond is the capital of Virginia.
All right, Greg, so you're my partner in crime here. We listened to 5 state capitals: Columbus, Louisville, Lansing, Harrisburg, and Richmond. Which one was the incorrect, capital? Is Greg still with me?
I am, sorry. Oh, man.
Are you Googling that right now?
I am totally Googling it.
Might
Okay.
need to phone a friend.
I think so, man. I am in trouble. I want to say, what? I'm gonna say Lansing.
Nope. Lansing is the capital of Michigan.
Oh man.
Betsy Ann, which is the incorrect answer?
So it would be 2. Louisville is not the capital of Kentucky.
Oh my God,
It's
it's
actually
Lexington.
a very charming town called Frankfort, Kentucky.
Frankfort.
So, Greg,
Lexington.
I told you at the beginning that I was going to tell, if there was time, I was going to tell a funny story. And so I'm going to get you off the hook. I'm going to tell this quickly. So go back 30 some years. You are Jim Sullivan sitting in business law with 200 other students when the business law professor says to you, that's like if I ask you the question, how do you pronounce the capital of Kentucky, Louisville or Louisville? To which Mr. Sullivan replies, of course, Louisville, in which 200 of my peers in the auditorium just laugh hysterically. Now, fast forward 2 weeks later, same class, right? Same business law professor asks the exact same question and points to a kid 2 rows behind me, and he responds, Louisville. So clearly somebody was not in class that particular day. So that's my funny story.
This is my, you guys found my weakness. It's capital. That's it.
That's what we'll do the next time. We'll do state capitals. All right, so moving along. All right, so let's go racing. All right, so what do I mean by let's go racing? So what I'm going to do is I'm going to hit escape now. And again, just bear with me as I play Zoom Jiu-Jitsu. What I'm going to do this time is I'm going to maximize this screen, but I'm going to actually, I think I need to maybe turn down my sound as well as I do this. So give me 1 second to get prepared. And actually, I'm going to stop sharing, and we're going to bring up some code for everybody so we can take a listen to this debugging exercise.
And while Sully's doing this, I want to emphasize that one of the biggest advantages of CodeJumper is that, yes, it's a tool that is really good at hammering home some really core understanding and foundational pieces of coding for blind and low vision students. But it's not just the tool that's used for teaching coding to blind and low vision kids. This is a collaborative tool that can be used to teach coding concepts for anybody, whether they're blind, low vision, sighted. And really, when we were looking at working with Microsoft on building this tool, it was so that blind and low vision students and sighted students can work together in a group in a classroom environment with the classroom teacher to be able to understand these concepts. So it does not, and it is not designed to be a separate tool to create or to learn the same concepts. It's meant to be a collaborative tool, right? So oftentimes I know that we in the assistive technology world are like, okay, well, if they can't use this, then they'll need to use this specialized device. And that's really, yes, this is a specialized tool to help a blind or low vision student learn concepts, but it's not meant to be something that excludes the sighted population, but rather is a different way to help kind of reinforce those concepts.
Okay, so we are running out of time, so we need to kind of speed things up, else we not get to everything we need to do. But all right, so think about that debugging exercise, right? So we went through those state capitals and we identified the wrong one. So then we would get into this discussion about how do we fix that? What do we need to do to change that? So, and in that spirit of engagement, the theme is racing. So I've downloaded some sounds with regard to racing. So you would need, right, if you're going to engage the kids, is everybody interested in racing? Well, maybe, maybe not. That ability to be able to come in and bring in a custom sound set to kind of get everybody moving forward. And so as we do this, think about the cast of characters that you are working with and who would be interested in racing and what would get that. And what do we need to know about a race, right? There's the start of the race, and how does a race start? And then as the race is going on, what's happening? What are you hearing? And then how do you know when the race is over? So those are some things that we might talk about. And then what are we going to listen for? And then how are we going to go about undoing or changing things, right? So for those of you who are race fans, you may get this. Hopefully this point will come across, but we're going to listen to this sound set, and I'm going to start by pressing the play button, and we'll go through it, and then we'll listen to the code. So here we go. I'm pressing the play button. Okay. All right. So if we know anything about a race, there's typically going to be the countdown, then the starter pistol, then we're going to have the race go on, and then we're going to conclude. And so what the kids can do is talk about that as a group. And then how can we go about figuring that out? Well, I'm going to go ahead and press both circles together so that we can listen to the code.
Thread 1 race day. Play Formula 1 normal speed. Play countdown 1.5 times speed. Play starting pistol 1.5 times speed. Play car accelerating 2 times speed. Play starting pistol half speed. End thread.
All right, so I'm going to go ahead and I am going to change my view here because we just have a couple of minutes. So leave it to us, Greg, to not get through everything that we need to get through. So bear with me. So when we talk about code jumper in expression, there are unplugged activities that show that physical relationships of abstract computing codes, and that assistive technology includes pods with knobs and dials and accessible applications, and that the kids have the ability to be able to journal, and that there's an outline there for both primary and advanced lessons. All right. In terms of engagement, it offers the opportunity for kids to be able to create their own code, right? They're doing it themselves. They're not listening to others or just passively participating, but actively participating. The projects can be relevant to culture and age, that ability to be able to bring in those sounds and, you know, who are your race fans out there? And then it allows for pacing and length of work of a session. So you can move at your own speed. So if some kids need to move a little faster and others need to move a little slower, you can do that. So today, with regard to what we've discovered, we've talked again.
I don't think your slideshow's showing up here.
Oh,
I think
thanks,
we're
Greg.
just seeing your pods.
All right, let me go back.
Zoom acrobatics take 4.
It didn't work. Didn't work. All right. How about now? So our discoveries. We discovered in the areas of expression, again, that there are unplugged activities to go over computer concepts, and that the kids are able to get at what's going on with accessible technology, like pods with knobs and dials. As far as engagement goes, alternative opportunities to create code, projects that are relevant to culture, and then with regard to Scratch and Blockly, well, they're similar because they're allowing kids to learn computer concepts creatively, but different in that you've got the opportunity to collaborate, and you can use things like music and sound. So we really need to give the closing code. So what we're going to do is I'm going to, sorry about this, everybody. I'm going to pause the recording.